This is worksheet 12-2. It's most of the gas laws, but not the ideal gas law. First thing that I did was I went to all the temperatures and I changed all the degrees Celsius to Kelvin. So you can see here, change temperatures to Kelvin. And that's a good strategy to go ahead and do that right at first and get it over with. Another thing you can do is just right away refer to your PowerPoint notes and realize that the unit kPa stands for pressure and the unit liter stands for volume. Right? You could go through the whole paper if you wanted to and label the numbers as to whether they're volume or pressure or temperature. Alright, once you've established what the numbers are, as far as whether it's a pressure or a temperature or a volume number, then the next thing you would do would be you would say, we've got pressure and volume, and that's all there is in this whole sentence. If it says the temperature remains constant, you just kind of ignore that because they're just saying that there was no change in temperature. So if we only have P's and V's, then the formula we would use would be Boyles Law. So it would be P1 V1 equals P2 times V2. Alright? And when you read the sentence, the volume of a gas at such and such a pressure changes from this volume. So this and this are our starting point. So I'm going to go ahead and put 155 as my pressure 1, and I'm going to put 22 liters as my volume 1. And the question is asking for what is the new pressure. So the new pressure is our, in other words, this is our unknown, and the other volume is going to that, so that would be then a 10 there. So then you would punch it in the calculator, 155 times 22 divided by 10 equals our unknown, and the unit would be kPa. Number 2, we've already established that liters is volume and Kelvin is temperature, and here's another temperature. It says what is the new volume? So we've got volume and temperature, and it says if the pressure remains constant, again you just ignore that. So if you have V's and T's, then Charles' law is the formula that you're going to use. These two go together, exactly 10 liters at this temperature, so those are going to be V1 and T1. And then here's the word 373. That's going to be our T2, and V2 is going to be our unknown. So then we'd plug in the numbers, we'd put a 10 milliliters there, and we'd put in our 258 here, 248 there. So we would cross multiply 10 times 373 divided by 248 equals, and this is going to be in liters, which, you know, volume is in liters, so there you go. The next question has lots of numbers in it, which is a clue that it might be the combined gas law. And if we go through and label the numbers, pressure, temperature, volume, temperature, volume, so we've got P's and T's and V's. And really the only formula that would meet that criteria would be the combined gas law. So we have a PV over T equals PV over T. So we have PV1 and all the PV2s. This is just a before and this is the after. So when you read the question, it says a gas at a pressure of this and a temperature of that occupies a volume of that. So all those numbers go in one side of the formula. It really doesn't matter which side, but you've got to keep them together. So P was 501, volume was 5.2, temperature was 298. Alright, so we've taken care of these numbers here, and now we need to take care of the other temperature was 373, and the other volume was 7, and the pressure that we're looking for is there. So then when you plug that into a calculator, probably the easiest way to go about doing it would be to cross multiply. So it'd be 501 times 5.2 times 373 equals 298, because I'm going over here now. And I like my question mark to be last. I'm going to go 298 times 7 times question mark. And then you would punch these in the calculator first, and then divide by the product of those two. And since we were looking for pressure, we were looking for pressure 2, kPa would be our unit. If we go and list and label, we've got a temperature here, we've got volume, we've got pressure, we've got temperature. Again, we have 5 numbers, which is a clue that it's going to be the combined gas law. When we read the question, we find the 3 things that go together. A sample of O2 with an initial temperature of this, so 323 is the initial temperature, an initial volume of 105, and is cooled to 298. So we have a new temperature here, 298. The new pressure, which would go here, 105.4, and the new volume is 55. What was the initial pressure? Okay, so we go ahead and cross multiply again. So I'm going to start with 32.3, excuse me, 32, is it 32.3? No, it's 323. 323 times 105.4 times 55 equals, I'm going to do 298 times 105 question mark. I would punch those numbers in the calculator first, and then I would divide that number by the product of these two multiplied. Next one, liters is volume, temperature is Kelvin, temperature is Kelvin. Since the pressure remains constant, that means we just ignore it. T and V. The only formula that has only T's and V's would be this one here. So I put 7.34 on top, and these two go together, so I put 313.8 on the bottom. This is a temperature, so I put that on the bottom. So that would be 7.34 times 250.3 divided by 313.8 equals